Let's see the converse of basic proportionality theorem. Though it is not asked in the board exam, but the result is very important. Okay, so please learn the statement. If a line divides any two sides, if a line divides any two sides of a triangle in the same ratio, then the line must be parallel to the third side. Okay, this is the statement. Now let's see how to prove what we are given according to the statement. Please note down given triangle ABC and a line DE, they are intersecting AB at D point and AC intersecting AC at E point, such that how they are intersecting. If they are intersecting, then we have this important result AD upon DB, which will be equal to AE upon EC. Fine. Let's call this is result number 1. Okay. Now what we have to prove? We need to prove. So please, before I draw the figure, I am mentioning what we have to prove. We need to prove DE parallel BC. Okay, let's draw the figure and try to understand its a proof. We need to prove if they are in proportion given. So we need to prove now these sides are parallel. Okay, this is the converse of Bpt theorem. Okay dear students, now we will continue with the converse of Bpt. You can see the figure here. ABC is a triangle. Okay, and DE, as we have written, what we are given in that ABC and line DE, it intersect AB at point D and AC at point E, so that AD upon DB, which is equal to AE upon EC. Okay, now let's see its a proof. Make yourself ready for the proof. In triangle ABC, observe carefully. In triangle ABC, AD upon DB, which will be equal to AE upon EC. Okay, so let's assume in that triangle ABC. Let's assume triangle ABC DE is not parallel to BC. DE is not parallel to BC. Let's assume for a while this DE is not parallel this line BC. So we are drawing. Now draw a line. Okay, as you can see in the figure, draw a line DF which is parallel to BC. For a while we are thinking DF is any other line which is parallel to BC, which intersect a point AC at point F. Okay, fine. This intersect AC at point F. Okay. Now applying Bpt theorem. Now what we are going to do on applying, let's apply Bpt, basic proportionality theorem. Then what do we have? We get AD upon DB, which will be equal to AF upon FC. Fine. Let's call this is result number 2. Okay, fine. This is C. Now from 1 and 2. From result 1 and 2, what do we have? You just keep this in mind. we have already this result AE upon EC, which is equal to AF upon FC. Okay, let's call this is result number 3. I am calling this is result number 3. Right? Let's see in the next part. Let's continue with the converse of BPT. This is third part. Okay, we got 3 results: result 1, result 2, and result 3. Now what we are going to do in the next step, on adding 1 to both the sides of equation 3, the last equation which we got, then we will have this result. What do we have? You can see AE upon EC already with us, and that is equal to AF upon FC. We have written. Now I am going to add plus 1 both the sides and taking LCM. If I take LCM, then of course I will have AE plus EC upon EC equal to AF plus FC upon FC. Okay, so can I say AE plus EC? AE plus EC. AE and EC combinedly gives the result AC. So AC upon EC, which will be equal to, this is also AC upon FC. It means that AC cancel. So the result, important result with us is, we can say EC equal to FC. EC cross multiplication FC. This is very important result. So we can say that finally, so we can say that, what we can say? We can say that the points, I am talking about points E and F. E and F coincide. Coincide, it means same point. They are the same points. Okay. So DE parallel to BC. Finally, we can say DE parallel to BC. Clear? That is, we can say what we have to prove according to this, DE parallel BC. This is the converse of Bpt theorem, hence proved. Okay, this converse is proved here. Clear to you?